I'm Kourtney Chinnery, and I'm presently a junior at Bridgeway Academy, and I will be presenting a chemistry lab. Today's date is February 3rd, 2016, and the title of the experiment is Lab Number 6, Oxidation Reduction. The goals of this experiment are to become familiar with single replacement reactions, to gain a better understanding of oxidation, reduction, and oxidation reduction reactions, and to better understand the reactivity of some metals. The background of this experiment is single replacement reactions are a common type of chemical reaction. In the case of metals, a more reactive metal will replace a less reactive metal. For example, elemental nickel will oxidize and force copper ions to reduce to form elemental copper. One equation for this is equation 6.1. Consider only the nickel and the copper and their ions in equation 6.2. Nickel is more reactive than copper and replaces the copper in this reaction. Since one element replaces another, this is a single replacement reaction. Consider only the elemental nickel and the nickel cations in equation 6.3. The nickel atoms each lose 2 electrons and are now cations with a charge of 2 plus or 2 positive. Nickel is oxidized since its oxidation number has increased. Ionic copper is the oxidizing agent since it takes part in the oxidation of nickel. Note that oxygen does not take part in this oxidation reaction. Now consider only the copper cations and the elemental copper in equation 6.4. The copper cations gain 2 electrons and are now elemental copper with a charge of 0. Copper is reduced in this reaction since its oxidation state is reduced from 2 positive or 2 plus to 0. Nickel is the reducing agent since it takes part in the reduction of ionic copper. In this reaction, nitrate is unchanged. It is a spectator ion. In this experiment, we have several materials that we will be using. We'll be using copper nitrate, iron nitrate, zinc nitrate, copper metal, iron metal, and zinc metal. And the equipment we used were my goggles, of course, the 96-well reaction plate, and sandpaper. So, for the procedure of this experiment, I used my 96-well reaction plate. I put 5 drops of copper nitrate in wells A1, D1, and G1. I put 5 drops of iron nitrate in wells A4, D4, and G4, and 5 drops of zinc nitrate in wells A7, D7, and G7. For step number 2, I sanded each piece of metal to remove any coatings, making sure the bare metal was exposed. I put a piece of copper in wells A1, A4, and A7. A1, A4, and A7. I put a piece of iron in D1, D4, and D7. And I placed a piece of zinc in wells G1, G4, and G7. Spreading the metals out helps prevent them from touching each other, of course. For step number 3, I just waited a few minutes because it took a few minutes for the reactions to take place. Step number 4, record which wells have a reaction in table 6.1. So I had table 6.1, and for my reactions, I noticed that the copper reacted with the iron nitrate. I don't know if you can see it from there, but yeah. And I noticed also that the iron reacted with the iron nitrate as well, and the zinc reacted with the copper nitrate and the iron nitrate. For the next step, I recorded which metals were oxidized and the respective oxidizing agents. For the metals, there were copper, iron, and zinc, as we said before. Was the metal oxidized? Yes, each of the metals oxidized. Copper was, the oxidizing agent for the copper was the iron nitrate. The oxidizing agent for the iron was also the iron nitrate. And the oxidizing agent for the zinc was the copper nitrate and the iron nitrate. So I'll be showing those to you. I don't know if you'll be able to see it, but you can see a slight bit of oxidation. You can really see it for this one. That is the zinc that reacted with the copper nitrate. And that is also the zinc that reacted with the iron nitrate. So those were the two biggest reactions. So nothing really reacted with the zinc nitrate. The most reactive metal was the zinc. The zinc turned black with the copper nitrate, as you saw, and it turned orange with the iron nitrate. The metals, overall, in conclusion, the rank of metals in increasing reactivity were the zinc. The zinc was the most reactive, then the copper, because it reacted with the iron nitrate, and then the iron. So also for this experiment, I realized that the zinc did reduce, and it the metals that acted as the reducing agents were the copper and the iron. So, or the zinc nitrate was reduced. So yes. So thank you for watching this experiment. Thank you so much, Miss Berg, and I had a great time, and it was a pleasure doing this experiment. Now, for the last step, I'll be cleaning the reaction plate and the metals thoroughly for safety.